Hi, I'm Raghu and welcome back to another session in the series of programming a Raspberry Pi Pico using Python. When we worked on relays, we checked the working of a relay by checking for the clicking sound and checking if the LED on the relay board turned on or turned off. While this technique is good enough for checking a code, the real use of a relay is to turn on or turn off electrical appliances. In this tutorial, I will show you how to connect a relay to the actual electrical device. To start with, I'll show you how to connect an LED strip to a 9 volts battery. Later on, I'll show you how to connect to the mains power source. A word of caution here. Live AC power source carries a high voltage and is extremely dangerous. Using it without caution can cause serious injury or even death. Please work on AC only when you're comfortable and confident working with AC power supply. I will use the Y not 2-channel relay module in this tutorial. There are a lot of 2-channel relay modules available in the market. Then why did we take the trouble of creating our own module? The existing relay modules just expose a relay's pins directly using terminal connectors. Remember what I explained about the relay pins? Each relay has 3 pins, A common, B NC and C NO. The relay modules have a 3-pin terminal connector directly exposing these pins. For example, a 2-channel relay module has 2 such 3-pin terminal connectors. There are 2 fundamental issues in this design. First of all, NC or normally closed pin is virtually useless. It's not used in almost 99% of the circuits. Second issue is that the design doesn't take into consideration the typical fashion in which these relay modules are used. Let's take the example of a 2-channel relay module. In almost all scenarios, you would use a 2-channel relay module to control 2 different appliances which are powered by the same source. For example, 2 lights or 1 light and 1 fan, and so on. That is, the input power source for both these would be the mains power source. If you use the 2-channel relay modules available in the market, then there are additional wiring required to make sure that the 2 relay modules are powered by the same source. This is unnecessary. We've addressed both these issues in the Y not relay modules and exposed the pins in a more intuitive manner. These modules have 3 numbers of 2-pin terminal connectors. One terminal is meant for the input power source. The connector is mounted separately and is marked as source on the PCB. The other 2 connectors are placed next to each other and are marked as out 1 and out 2. These are the output connectors and they should be connected to appliances. For the trigger part, the Y not relay module has a 4-pin RMC connector. You could either use a 4-pin RMC female wire pair or use DuPont header wires. Let me now show you how to connect the Y not relay module. To start with, let's use a 9 volts battery as the power source. For all projects, I recommend that you use the 9 volts battery source to start with and to build your prototypes. Using the 9 volts battery removes the risks associated with AC power source. After completing all your projects, if you want to deploy your project in an actual environment, you may go ahead and use AC power. The 9 volts battery comes with a snap. Connect the snap to the battery. Now, take out the positive wire from the battery snap and connect it to the pin marked as L on the source terminal connector. L stands for live. If you use AC, you have to connect the live wire from the power source here. But since we are using DC, we are connecting the positive wire to this pin. Connect the negative wire from the 9 volts battery to the pin marked as N in the source connector. N stands for neutral. The positive wire is red in color. For the appliances, we'll use devices that work on 9 to 12 volts DC power. I'll just use one appliance, which is a small LED strip. Connect the positive of the LED strip to the terminal connector's pin marked as L. Connect the negative wire to the pin right next to the positive pin. When you place the Y not relay module in a way such that the 2 output terminal connectors are in the bottom, then the leftmost connector is out 1. For each of these connectors, the left pin is positive or live, while the right pin is for the negative pin or neutral. To test this connection, I'll use a small variant of the LED blinking code. When I run the code, the LED light connected to the relay continuously blinks. I will now show you how to connect the Y0 relay module to live AC power. Once again, I have to warn you that live AC can cause severe injury or even death. Be extremely cautious when you work with AC power. First thing you have to make sure before connecting AC is to make sure that the wires are disconnected from the power source. You can test for a live power source by using an electrical line tester. If there is live power, then the light on the tester will glow. After disconnecting the power source, connect the live wire to the L pin of the input terminal connector. Connect the neutral wire to the N pin of the input terminal connector. Now let's connect an appliance. I will use a simple light bulb. Connect the two wires of the light bulb to the two pins of the out1 terminal connector. Since this is a light bulb, polarity doesn't matter. That is, you can connect the two wires of the light bulb to any two pins of the out1 terminal connector. With the same code as before, when I execute, the light bulb blinks. Hope you enjoyed this session and have got a good understanding of the concepts that we learned here. So let's move on to the next session in this series of programming a Raspberry Pi Pico using Python. So see you soon.